Hi, Algebra 2. These are the notes for section 7.3, which are logarithmic functions as inverses. So when we were together in class, we walked through kind of a discovery activity. So instead of using the term log, we used power. So power 2 of 8 equals 3. And we spent some time thinking about what that statement meant. And eventually you took a look at the numbers and you recognized that 2 to the third is equal to 8. And I intentionally withheld the vocabulary term log from you. I wanted you to kind of make the connection with the powers, the exponentials first. But once we introduced the concept of log, we asked a question. So we said, what this is saying is what exponent is required on the base to get to this value, right? So log base 2 of 8 is saying what exponent can I put on 2 to get a value of 8? So in class, we walked through a couple of examples and kind of just said to ourselves, what exponent can I put on 3 that gives me 81? Oh, that's 4. What exponent can I put on 4 that gets me to 16? Oh, 4 squared. So it's 2. Log base 5 of 5 means what? What exponent can I put on 5 that gives me 5? Oh, that's 1. 5 to the first power is 1. And so we also said you could think about it this way. The log is the exponent. And the base of the exponential and the base of the log are going to be the same. The base is the base, the log is the exponent. So here's kind of a roadmap that helps you make sense of translating between the two. So you could see in red, there's your log is the exponent. So b to the x equals a, log base b of a equals x. The base b in green is the same in both situations. Right? And then a in blue is your argument of your log, and that ends up being the value of the exponential equation. So let's look at a couple of examples. Write the exponential in log form. 9 to the second power equals 81. So the base is always going to be the base. So if it's 9 to the second, this is going to be log base 9. And we know that the log is the exponent. So equals 2. So what remains is 81. 9 to the second power equals 81. So log base 9 of 81 equals 2. How about this one? The expression log base 5 of 1. So this is saying what exponent can I put on 5 that gives me 1 for a value? And then we remember our 0 and negative exponents. Any non-zero number to the 0 power equals 1, so this is 0. All right, a little more challenging one. We have log the base 1/2 of 8 equals negative 3. And our job is to write this as an exponent. So we look at these three, we don't really see any relationship that forms between 1/2, 8, and negative 3. So our head starts to spin a little bit. And I picked this problem intentionally in class because I wanted to force you guys to have to kind of see the pattern and plug the parts into the pattern to see how this works. So we know the base is always the base. The log is the exponent. So 1/2 to the negative 3 power is equal to 8. And yeah, that makes sense now. 1/2 to the negative 3 is the same as the reciprocal, 2 to the positive 3. 2 to the third is equal to 8. And again, that one was intended to be challenging. All right? So I want to share a quick memory device with you. Okay? A teacher that I'm connected with online, she uses this with her students. She uses this loop method. So the base of your log, she loops that to what's the value of the log. So base to the power equals the value. Right? 2 to the third equals 8. So let's go back and take a look at what would happen in this case right here. 1/2 to the negative 3 is equal to 8. Right? So once we start seeing that loop, it's really getting a lot easier to translate from this to this, especially when this is a little bit ugly. So this one was a little bit more straightforward. 144, if you remember memorizing your multiplication tables in grade school, 12 times 12 was about as high as that went. So 144 was probably the biggest number you could think of when you were 3 years old, at least that you would ever get asked about in school. So 12 squared equals 144. Wanted to remind you that there's a couple of logs that occur so often that we have special notation for them. One of them is called the common log. Right? Any log with a base 10 is called the common log. Right? And because it happens so often, 10 to the power gets used over and over and over in math and science and engineering, that we don't even write the base of 10. We just write log and then the argument. So any log written with no base is assumed to be base 10. So if you saw something like this, log of 5, that's saying the log base 10 of 5. All right, so we're asked to rewrite log of 1,000 as an exponential. So recall that this is the common log base 10. So thinking of our loop method, we're going to have 10 to some power equals 1,000. Now in class, a lot of us said, oh, it's 10 to the third because we know that 10 to the third is 1,000. But just rewriting this expression as an exponential, the 3 is not in here anywhere. We're just writing this as it is. So 10 to the x equals 1,000. And the last thing I wanted to touch base on is we're kind of really getting the sense that exponents and logs are related. They're inverses. They undo each other, right? So if we take a look on this next screen, the log function in blue, that's y equals log base 2 of x, and the exponential function in red, the parent function y equals 2 to the x. And you can see that the exponential function, it's got a 0.01 on it. The log function has the 0.10 on it. And we can see that we're going to have pairs like that all the way along the line. So the 0.24, I'm going to have the 0.42 on the log function, right? The black dotted line, that's the line y equals x. And you may remember from geometry that when we reflect a function over the line y equals x, and maybe from algebra 1 this came up too, that those functions are inverses. Okay. So I did put an opportunity for independent practice in Math Excel. If you need to go back and work on that some more, you most definitely can, and bring your questions with for next time.